Today, ladies and gentlemen, we're going to discuss standard deviation. This is the first discussion that we're going to have in our new probability and statistics unit. Standard deviation, what is it? What does it tell us? How do we calculate it? Two classes took a recent quiz. There were 10 students in each class, and each class had an average score of 81.5. Since the averages are the same, can we assume that the students in both classes all scored pretty much the same on the exam? The answer is no. The average, or the mean, does not tell us anything about the distribution or the variation in the grades. Now let's look at a couple of examples here of dot plots in each class. Here I've graphed the scores from Team A and their quiz grades. And here's Team B and their quiz grades. Now you can see visually that the lowest grade in Team A is about 72 and the highest is about 88. And the lowest for Team B is about 57 and the highest is about 98. So they do have the same mean or the same average. Now, we need to come up with some way of measuring not just the average, but also the spread or the distribution of the data. Why not just give an average and then the range of the data, the highest and lowest values, to describe the distribution of the data? Well, for example, let's say in a set of data that the average was 17.95 and the range was 23. And then what if the data looked like this? Well, here's the average, here's the range, but the average and the range do not tell us that there's this big group of scores in the middle, and there's no way to know just from the average and the range that you've got so many scores so close to the middle. The standard deviation is a number that measures how far away the numbers in a set of data are from their mean. In other words, how spread out the numbers are. And if the standard deviation is larger, it means that the numbers are more spread out from their mean. If the standard deviation is smaller, it means that the numbers are closer to the mean and less spread out. So here, back to the original example I was talking about, here are the scores on the math quiz for Team A. The average was 81.5. And standard deviation measures how far away the numbers in a set are from their mean. For example, if we start with the lowest score of 72, how far away is that from the mean of 81.5? Well, it's 9.5 points away. And then if we look at the highest score, 89, how far away is that from the mean? 7.5 points away from the mean. Now, if you take all of those scores and measure how far away they are from the mean, you will have this list of distances from the mean. And so what we do to figure this out is we square each of the distances, turning them all into positive numbers, and then we list them, add them together, take the average, and take the square root of that average. Now, I went through that quickly because I don't expect you to remember how to do that. I just wanted you to see and understand how it works. And so this group of data has the average of 81.5 and a standard deviation of 4.63. If we do the same thing with the other class, we find that the standard deviation is 15.1. So both Team A and Team B had average scores of 81.5. But the standard deviation is very different between the two. So that means that the scores for Team B were much more spread out than the scores for Team A. And you can see this visually in these two graphs. You can see that the spread for Team A is not as great as the spread for Team B. But in real life, you would not be, let's say you worked for the testing company that does the SATs, and you were trying to figure out the average and the standard deviation. Nobody at SAT headquarters sits at a desk and calculates this. They have a computer do it because it's thousands or millions of pieces of data. And so rather than knowing how to calculate standard deviation, you need to know what it represents, because we will be using standard deviation in an upcoming lesson.